Happy day and welcome everyone. We are doing the Le Chatelier lab today. So this is systems in chemical equilibrium. So what I'm going to do first is just kind of run through a little bit of the lab with you, a little bit of the introduction, what's going on, and then tell you about what your tasks are, and then we'll go right into part 1, part 2, and part 3, and then you'll end up filling out your lab sheet on your own. Okay, so as an introduction, so some chemical reactions proceed essentially to completion. A piece of magnesium, you can ignite it and the oxygen burns all of the magnesium until it's been converted into magnesium oxide and actually forms this like white powder, and it burns this like bright white light. Other reactions proceed for a while, but they appear to stop before any of the reactants are all consumed. If we have a system in a chemical equilibrium, we can alter the position of the equilibrium. So basically what we're doing is the equilibrium has been established, so the reaction comes to a point where it's just kind of sitting there waiting, and then we throw in some type of change. And when we change something, the reaction is going to shift to try to relieve the stress of whatever that change was that you made. So it says the extent to which reactants are converted to product by changing the condition. In all cases, the system will respond in such a way to counteract the change that we try to make. If we increase the concentration of a reactant, the reaction is going to go opposite and it's going to form products, and thereby decrease to some extent the concentration of the reactants that we increased. If we add a product to the equilibrium mixture, the reaction occurs to the left. It's going to shift opposite to decrease the concentration of the product that was added. Similarly, if we try to raise the temperature of the system, the reaction occurs in such a way that's going to absorb the heat change. So it depends on whether it's exothermic or endothermic. In an endothermic reaction, the addition of heat energy will cause the formation of more products. If we increase the temperature of an exothermic reaction, the reaction is going to proceed to produce more reactant. So I always say it's always easier to simply add heat into the equation. So if it's endothermic and you put it on the reactant side and you add heat, that's similar to adding a reactant. It's going to shift to make more products. If it's exothermic, the opposite's going to happen. Okay? And so what you can do is you can pretty much use the data and use the balanced equation to figure out, especially if there's a color change, for example, you could figure out what side is being favored, and then you can kind of work your way backwards to figure out if it's exothermic or endothermic according to what color it changed to, for example. Okay, or if you know what the substance is, then you could figure it out that way. So maybe you've got aqueous substances, but then there's a gas that forms. And so if there's a gas that forms and you're like, oh, the gas is on my product side, it must have favored the product side, for example. Okay, so we're just going to go right into part 1 and part 2. And then what you're going to do is you can pause as needed. You're going to end up answering the questions according to each section. Now, normally in lab, the way that this would work is we would have different stations, and so you could be working on part 1, part 2, or part 3 first. It doesn't really matter. They're all kind of their own little entities, so I just called it part 1, 2, and 3, but they don't have to go in that order. So let me just show you what we have here. Okay, so I have all of my equipment ready for part 1. So part 1 says, some dyes undergo remarkable color changes when the concentration of H+ ion is changed in the solution in which the dye is present. The color changes can be used to determine the hydrogen ion concentration, so the dye is called an acid-base indicator. And so what we have here is we have bromothymol blue inside of this container here, and so you can see there is my bromothymol blue. Okay, so it says, in acidic solutions at relatively high hydrogen concentrations, bromothymol blue is actually yellow. In basic solutions where the H+ is low, bromothymol blue is blue. So I always like to remember that a lot of times bases are blue and they both start with the letter B, so that kind of helps. At certain H+ concentrations, equal amounts of blue and yellow are present and the solution's green. Denoting the blue color as B- and the yellow color as Y, we can write the chemical equation as, and so you can see the chemical equation written under part 1 as H+ plus B- being the blue yields Y, the yellow. Okay, so it says pour about 5 mils of distilled water into a regular size graduated cylinder, and then we're going to pour it into the test tube. So I already put the 5 mils in here, and so I am simply going to transfer my 5 mils right into my test tube. Okay, got that. it says add 5 or 6 drops of the bromothionyl blue to the water and then mix it. Okay, so let's open this up and let's add about 1, 2, 3, 4, 5, 6. So we've got our bromothionyl blue added in here, and so you can see a little bit more of the greenish color, right, which is just the water inside of there. Okay, and then it says, then add 5 drops of 0.1 molar HCl. Be careful, there are many concentrations of HCl. Be sure to read the label carefully. Okay, so I want the 0.1 molar HCl, which is this one right here. So I'm using the 0.1 molar. And then let's check to see what happens when we add about 5 drops to this. So you can see it's kind of like this green color right now. 1, 2, 3, oh, I missed one. 4, 5. Maybe 6, but it's okay. Okay. Oh, what? Turned yellow. Okay. So it says record. You have now increased the concentration of H+, because we added acid to it, and H+, HCl, will actually break up and form H+ and Cl-. So I know that I just added H+ to it. It says now, drop by drop, add the 0.1 molar NaOH. So now I've got my NaOH here, and I'm going to start adding drops. It says this will decrease the concentration of the H+. Here's why. When you add the NaOH, the OH- wants to react with the H+ to make water, okay? To make water as a liquid. And so that's why it's going to actually decrease my H+ concentration. So I'm going to start adding this. There it drops. There we go. Oh, I can already see, I don't know if you're seeing this, but I can already see that it's starting to go towards that green color. Oh, look at that. Okay, so I know that by adding the OH-, it's actually starting to reverse. Oh, there we go. Okay, looks like it's still in that, like, keeps kind of switching back here. So let's add some more here. Okay, and so it looks like it's going to be blue. Let's see if it stays. Oh, yep, and staying blue now. Okay, so that was probably about 10 drops or so, something like that. And so I was able to get it back to go to a blue color, and actually deeper, right? Because we only had it as a green before, and so now it's going to a blue color. Okay. All right. So it says you've just reversed the chemical reaction and caused the equilibrium to shift from product to reactant, then back to product, kind of giving you a little bit more information than you even need to know. I want you to pause now and go ahead and answer your questions for part 1, and we'll be back for part 2. All right, part 2. Okay, so what I have here is I have a potassium dichromate solution. It's a 0.1 molar solution. And then for this one, we actually need some of the 1 molar HCl and the 1 molar NaOH solutions, okay? And so what I've already done is it says to pour 5 milliliters of the 0.1 molar K2Cr2O7 into a test tube. So I've got my 5 mils prepared here. And kind of cool, this potassium dichromate happens to be like orangish in color, so kind of cool there, okay? And so it says convert the dichromate ion to chromate by selecting the proper reagent from the following pairs and add it to the dichromate ions in solution. The 2 reagents that we have to choose from are either the 0.1 molar NaOH, or I'm sorry, the 1 molar NaOH or the 1 molar HCl. So those are the 2 that we have to choose from. So let's think about what the addition of H+ and OH- did to the equilibrium in the first reaction and apply this knowledge. Okay, let's take a look for a second here. So this is the reaction that they're talking about here. And so we know that we've got an orange color right now, which means that I've got this dichromate ion, which makes sense because it's K2Cr2O7 and that ionizes, and so I've got the Cr2O7 2- ions that are taking over in here, okay? What we want to do is we want to turn it into this yellow stuff right here, okay? So the question is, do we add HCl, which HCl is going to break up into H+ and Cl-, or do we add NaOH, which is going to break up into Na+ and OH-? Okay, so let's think about this for a second. Before we even do it, and I want you to just think about this, if this breaks up and I add H+, then I'm essentially adding this, which is on the reactant side. What do you think will happen if I add H plus to it? Okay. If I add NaOH, people will say nothing happens. Well, that's not true, because just like I said before, the cool thing about acids and bases is that the H plus and the OH minus actually want to come together to form water, to form H2O liquid. And so if I add NaOH, the OH minus will actually attach to the H plus, which is similar to removing the H plus, and essentially it's like I'm adding water. Okay, so you're removing H plus, taking it away. Remember, what does Le Chat say? If you take something away, what do we want to do? Or it's also similar to adding water, because when I add the OH minus or the NaOH, the OH minus will form H2O when it bonds with the H plus. Okay, so think about it and let's see if you got this right. Okay, so I've got my potassium dichromate here, and so I don't know, did you guess that we were going to add HCl to it? Well, let's check to see what happens when I add HCl to this. Okay, so I'm going to start adding drops of HCl, and let's see, drop, 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 drop. It's orange. I don't know. We do something wrong? Did we? Because this happens all the time in lab, okay? And then students are like, nothing's happening, it's not working. Okay, well, let's see what happens when we add the sodium hydroxide to it. All right, and so let's go to and start adding some of the NaOH to this. Okay, I don't see anything happening. I don't know. Is anything going to happen? I don't know. I don't know if anything's happening right now. Oh, maybe. Are we sensing a little bit of a lighter color here? All right, we've got the sodium hydroxide here, and let's see. Got some drops here. Oh, okay, something's happening. I'm seeing, okay, something's happening there. That was about 10 drops. Let's see. Okay, I don't know what you guys think, but that looks pretty yellow to me. Okay, so adding the sodium hydroxide got it to go to the yellow color, okay? So hopefully this helped to try to figure this out, and it says convert it back by when you have obtained the chromate ion, the CrO4 ion in solution, now convert it back to Cr2O7 by selecting the proper reagent. Well, obviously now if I take the HCl and I add the HCl back again, I should make the dichromate ion again. So, oh yep, sure enough, it's going back to orange, everybody. There we go, going back to orange, okay? And so just, you can go back and forth, and that's kind of cool, the cool thing about adjusting the concentrations and getting them to go back and forth. I did want to mention, by the way, that we know that water is a liquid, and so a lot of times people will base something on like the liquid and say that water is a liquid, and so if I add water, then it's going to shift opposite. We're really not supposed to say that. So if there's a different ion or something like that that's in your reaction, focus on that one instead, okay? Because we really don't want to say that it was water. We're trying to keep that constant, okay? So that would fit in with your equilibrium constant. All right, we're going to move on to part 3. Okay, so this next one says, in water solution, the cobalt ion is pink. Cobalt 2+ is pink. The color is due to it's called a complex ion. So there's cobalt with water attached to it, and it's got 6 water molecules attached to it. It says, don't let the long formula bother you, which is the form in which the cobalt ion ordinarily exists in water. So it actually attaches a whole bunch of water molecules to it. If Cl- ions are present in high concentration, it's possible to be able to convert that complex ion to a species containing Cl- ion. And so you can see it's no longer an ion anymore, but it's the cobalt with 4 water molecules attached with chloride ions as well inside of there, and that happens to be blue, okay? So we can see the reaction, and so it's got the pink, and then it's got the blue. So when it's just with the water, it's pink, but then with the chloride ions added in, it's actually blue, and it does form a cool cobalt blue. So if you've ever had to buy a paint color, cobalt blue is a cool color. So it says the two colored cobalt species can be converted back and forth between each other simply by changing the temperature, okay? So number one, prepare a solution of cobalt chloride by dissolving the 0.5 grams of cobalt chloride in 10 mils of 6 molar HCl in a small beaker. So I have a small beaker here, and so what I'm going to do is I've weighed out 0.5 gram of the cobalt chloride, and I'm going to show you what it looks like. It's kind of cool. It's kind of like a pinkish, like, I don't know, hot pink, almost like a magenta color, I would say. Show you a bigger piece. I think I have a big chunk of this here that I can show you. So it's kind of cool. It's definitely like a purplish pink kind of crystal-y looking deal. Okay, and so that is the cobalt 2 chloride. And I'm going to take, to make this, I'm actually going to add 10 milliliters of 6 molar HCl to it. So I've got some hydrochloric acid, more caustic. The other one we were using was 1 molar or 0.1 molar. This one's stronger. So I'm going to take and I'm going to add, I already have 10 milliliters of this prepped. I'm just going to add 10 milliliters of this to it. And this should form what I was talking about, which is that CO with the H2Os attached with the Cl2, okay? And kind of cool. It's like a purplish color, actually, okay? So that's like a nice, pretty, like, kind of purple. I know it might look a little bit blue to you, but from my perspective, it's kind of violet. It's like a deep violet color, okay? So it says, you don't have to weigh out the chemical, just take as much as shown in the sample next to the bottle of chemical. We already did this anyway, and observe the color, okay? So that's our observation, is kind of this like purplish color. Prepare a solution of cobalt with the water by dissolving 0.5 gram of the cobalt chloride in 25 mils of water in another small beaker, okay? All right, so I have another 0.5 grams of this. I have about 25 mils of distilled water in here, so that one had the acid in there. This one is just going to be the cobalt chloride. And let's give this one a nice little stir here. So let's stir that up and let's see what happens. Okay, it says, observe the color. Okay, so this looks to me like it's more of like a pinkish color. Okay, especially in comparison to that, that's definitely more of a pink color. To the solution prepared in 1A, add water slowly. When the color change appears to be complete, put the beaker on the hot plate and bring the solution to a boil. Okay, so this is the cobalt chloride, so I'm going to keep this here. To this one, it says that we want to slowly add water to it, and then once the color change appears, we're going to put it on the hot plate. Okay, so let's add water to this. Oh, okay, what? Okay, now I'm adding a substantial amount of water. Okay, so this isn't just like a little bit of water. I'm adding a lot of water to this. Okay, so I'm definitely noticing a color change. You're probably noticing a color change too. Okay, and now I've got this pink color. Pretty cool. Okay, so that was number 3. It says put the beaker on the hot plate and bring the solution to a boil once it changes color. Okay, so I've got a hot plate already going here. So let's put it on the hot plate. I do have some beaker tongs that are here as well. So let's get this going on the hot plate. Okay, so I want you to pause and see if you can answer some of the questions if you want to while we're waiting. Oh, we don't actually know. We don't even really have that much time. Okay, so I'm going to show you what's going. I don't even need my beaker tongs right now because I know the glass didn't even really have time to get hot. But I don't know if you can see this. On the bottom, it's already starting to turn purple. It's starting to go back to this like purplish color. And so, oh, what? Okay, this is happening. It's happening. Okay, hold on a second. So let me see if I can move this closer because this hot plate is warm right now. So let's see if I can put this a little bit closer so you can see. Okay, looking good right now. Let me give it a little bit of a stir. So the bottom of it is actually turning like more of like a violet, like purplish color. Okay, let's read what number 4 says. It says, turn off the hot plate after you see the color change and then allow the solution to cool. This information is needed to determine if the reaction is endothermic or exothermic. Oh, okay then. Okay, and we can see, oh, look at that. Let's turn up the heat just a little bit more. I'm going to get it to like a high setting. I might need to use my beaker tongs in just a second, so let's get my beaker tongs ready here, just in case. Okay, definitely seeing a color change. So that's kind of one of the things that you want to do is you kind of want to have a control. So this was simply the cobalt chloride in water. That's all this was CoCl2 dissolved in water. Remember, this was originally in the acid. Oh, and now we've got it. And then remember, it was purplish, and then it ended up changing colors after we added water to it. Okay. Ooh, looks like it's going to an even darker color. Okay, let's wait and see what happens. Okay, I don't know about you, but I'm picking up a lot of blue here. Okay, so let's take a look and see. Let me try to see if maybe I could just hold it. And sometimes it's safer to actually, I do a tap test, by the way. So I do a tap test on the glass to see if I can actually hold the glass. And so that's definitely looking like blue to me. So before it was purple and or violet in color, and now it's definitely looking like a deep blue. Okay. All right, and so you're going to fill out your lab sheet. I hope you enjoyed the lab. Happy day, everybody.